So this is our talk, Drive-Thru Intelligence, Video Analytics for Restaurants, and we're going to talk about how to use visual data to turn high demand into high profit. Quickly, the agenda is going to be, we're going to do brief introductions for me and Denny. We're going to talk about what computer vision is and kind of how it's set up right now across different industries. Then we're going to talk specifically about some industry challenges for quick service and fast casual restaurants, and how to apply computer vision to help address kind of those different challenges. And then we'll go into some specific examples and kind of break down how you can do this with computer vision and talk about how some companies are already employing vision AI in their locations. And then we'll talk about how to get started, and we'll be hanging out around for Q&A. So if you have any questions, you can post them as we're talking. We'll try to get to them. No promises that we'll see everything as we're going. But if we don't get to it, hang around at the end and we'll have plenty of time for Q&A there. This slide is just to remind us to hit the record button, but we already did that, so I'm gonna skip it. So computer vision enables businesses to generate new insights from visual data. And for restaurants, this often means faster service, more accurate orders, or increased customer personalization. And of course, there's a lot more applications that you could use vision AI for in the industry. But we're going to kind of break some of these down, some of these use cases down today. Quick introduction. So my name is Sage Elliott. I'm a developer evangelist here at Plainsight, and I have a background of doing computer vision across in different fields. And specifically, I got started in manufacturing. And there's a lot of crossover of like what you can do with visual data in manufacturing and kind of the restaurant industry and many other industries in between. So I've done a lot of actual programming of those applications and tying all these different platforms and services together to work together to build an end-to-end application. And Denny, if you want to do a quick intro.
Yeah, sure. So welcome everyone. I've spent my entire career in technology. I'm the VP of Enterprise Solutions here. And in the early days, I was working on virtual reality. That was like back in the, early 90s kind of things. Then I spent some time in location-based services, working with mapping companies. And then I did some digital advertising. And then most recently, really over the last 4 years, focused on IoT and then more specifically computer vision. So I've really spent a lot of time with brands and enterprises over the last few years, really trying to understand their digital transformation process, and more specifically, how we can apply computer vision to help speed up and automate those processes. So just a little bit of introduction in terms of how the AI ecosystem is set up today. It's actually pretty fragmented and it's complex. There are a lot of different tools that you need to create a repeatable end-to-end solution. And we've listed some of those here. There's actually way more than this. And then of course, all the different stakeholders in the organization are looking for their own unique aspects and output from what occurs. And so, what the data engineer wants out of it is different than what a business engineer wants out of it versus an ML engineer, for example. So, in addition to that, the worker shortages are a growing problem. And so it requires really specialized engineers and expensive data scientists and so on to be able to pull this all together and from an end-to-end sort of solution process. So what we've done really is to try and streamline the whole process. So Sage, if you go to the next slide, this is what we've done. We've tried to narrow it down to really 5 key components of the machine learning lifecycle process, from collecting the data to labeling it, training it, deploying it, and then operationalizing it. So we've taken all those tools that you saw on the last slide and we've built them into a single unified pane of glass, so to speak, to streamline that whole process and allow someone, even down to a business user, somebody that has experience with the data, they know what they're looking for, and they have domain expertise, to allow them actually to build their own machine learning models and use the platform. So it's an end-to-end platform. There's no coding involved, and it really then gives everybody across the board the ability to see what's going on and to pull out the data that they're looking for to help with their particular needs.
Yeah, this is really cool because this slide looks very familiar to me when I built my application. So again, it's like you're kind of taking all these different frameworks and services and trying to get them to work together in a hopefully fairly seamless way as much as you can. And often that's a lot harder than it sounds, right? Like doing all these different steps of like collecting the data annotation, training a model, deploying it, and then maintaining that model once it's deployed. There's a lot of steps that go on there kind of with all these different frameworks involved.
Yeah, and I'll say too that we built this platform to be able to put it into your hands if you want to use it and if you have the resources. Most of the time in the beginning stages, we're obviously doing a lot of hand holding and we're doing a lot of the building of custom models and things like that. So no worries there.
Just real quick, so we've used the term already a little bit, but I wanted to break down a little bit, what is computer vision if you haven't really seen a lot of applications before. So, it's a pretty big field, but essentially I usually boil it down to, the way that a computer or AI can kind of gain insights or understanding from images or videos. So in this case, we have an example to the right where there's a foreign object in this tomato processing line. In this case, it's a rock bouncing around, and we can see where we're detecting it and tracking it. There's a whole bunch of different types of computer vision models you could use for this, and selecting that depends on what's the end result you're looking for from this application. So here, we could send an alert saying there's a foreign object in the line. Maybe we want to stop this conveyor belt. And we could do that with just a model that could understand if something was in the line or not. But here we're actually segmenting out or detecting, pretty closely where this object is in that line. And this allows us to do things like we could stop that line. You could use potentially a robotic arm to pick out that object, or you could send the coordinates to an employee. So instead of just stopping the line, you say, I'm gonna stop the line. If this is a really big conveyor belt, you could say it's in this area, go pick that rock out. You can even do things like understand the size of this object. So we could detect a foreign object. And then if this was, maybe small enough and we weren't worried about it in our processing here, we could say, well, it's a pretty small one. Like we're not worried about it, but potentially in this use case. So typically, right, like if there is something a human can see, often you can do that with computer vision. And in some cases, it can be, with greater detail, with greater accuracy, and then definitely the reliability piece is a big one there. So, machines don't really get tired. They're really able to focus on what you ask them to do. And with that, I'm going to hand back over to Denny to talk about some people in the restaurant industry already using computer vision.
Yeah, so computer vision is a growing area, rapidly growing area, and we're already starting to see some major brands in the restaurant industry starting to use it. Chipotle has reported that they're using it for guacamole insights, understanding how much guacamole is being used and how much they need to be making on a regular basis and trending on and so on like that. Also, Yum Brands is using AI vision in the back room, the kitchen, for example, to ensure order quality, QA, and QC sort of purposes. Those are just two of them. We're working with another large brand where we're looking at scoop portioning and trying to understand how much is in the scoop, how much is left in the front, and then sort of informing that in terms of how they need to fire more food in the back, for example, so they don't run out as more people are coming in the door. So those are just a few examples of what's happening currently in the restaurant industry.
I love the guacamole use case. If I want guacamole, I always want it to be available,
Don't want to run out of guacamole.
So here we're going to dive into a specific use case, which is drive-through efficiency and performance.
Yeah, so since the start of the pandemic, we've really seen the drive-through visits increase. These sources are coming from a C-level drive-through study, but by at least 27%, depending on who you are, it could be more than that. Which is great news, right? Except that the wait times have increased by almost a minute, and inaccurate orders have risen, of course. And then, there's costs associated with those types of things. And in fact, Chick-fil-A reported, I believe, that they were seeing like a 30% line abandonment because the lines were just too long. So I think we're going to continue to see this increased demand. It'll be here to stay. And Sage is now going to walk us through sort of what the drive-through looks like as when you apply computer vision to it, and how we can automate that whole process.
Yeah, so let's take this camera feed, for example, and we're going to kind of break down how we can go and build a application to monitor and collect drive-through insights. And just keep in mind as I'm going through this that this can be applied in all sorts of different locations, not just drive-through. Like you could use a very similar thing inside the restaurant and monitor, for example, people standing in line, or kind of probably anything you could think of. So here, again, we have this camera feed, and this is kind of an example of using an existing camera in a location too. This might not be the most optimal view to necessarily do all these analytics, but we're going to talk about how we can make it work for us and show the flexibility of computer vision in this type of application. So we want to capture data related to customers who leave the drive-thru early. We want to track and count the vehicles going through and understand their dwell time, like how long are they waiting in line for. And then we're going to hopefully, take that data and make improvements or adjust the workflow to hopefully increase the speed of getting food out to customers.
Just as a reminder too, feel free to ask questions in the chat as we go here, and we'll try to get them knocked down for you.
So the first step in most computer vision applications is creating a data set and training model on it. So, and here we have this feed set up. We'd be collecting this information on cars. We'd probably already have a model that actually works pretty decently on collecting cars because it's a fairly common task in computer vision. So we could start it with that, but then we'd want to keep collecting this data, label the cars in this video so that our model would be incredibly robust at this specific angle and at this specific location and in different lighting situations. So we would use the labeling tool inside the Plainsight platform, which has a lot of really cool AI-powered applications to help you label. Here's an example of using something called auto label, where we're actually taking a pre-trained model in cars in this specific case and automatically applying labels to cars in this image. So we'd use something like this, where you either use auto label to get those labels done, or we have smart polygon selection called smart poly, where you can drag a bounding box around the object you want to label and automatically find that object within that box and trace around it very accurately. And we have something called track forward, which is great for this use case too, because what we do there is we label objects in sequences of frames that are from video. So we know that they're going to move a little bit frame from frame and automatically apply those labels as it moves through. So there's a lot of ways built in to really, really make data annotation much quicker and much way more seamless than a lot of other applications that I've used.
Yeah, and so the labeling portion of this whole process is really key as well, because it really determines the accuracy later down the road in terms of how accurate you can make the model.
Yeah, and we can go into more detail like after the talk if people have questions on data annotation. I have a whole blog post that I actually wrote about it, and it talks about the different types and common mistakes and stuff too. But we're not going to go into a ton of detail here. So once we have a labeled data set, this could be hundreds or thousands of images potentially with a whole bunch of different cars. We want to use that data set, then train our computer vision model. So that's what's going to allow it to understand what we're looking for. So in that case, it would be cars. Here's a little visual showing stop signs. We would label these, for example, with like a bounding box. Then we'd feed that into the Plainsight Smart ML platform, which automatically figures out kind of the best parameters for your computer vision model, depending what you want to do. So like object detection, in this case, like drawing those bounding boxes around an object. We would feed that data in, and then would automatically learn, the best model to detect, in this case, stop signs. And that's based on the data set. The model's making adjustments and figuring out what we're looking for specifically. So once we have that model trained, we can start applying it to our video, almost, except for in this case, right? Like this kind of shows the flexibility and some common problems that come up, especially if you're using existing cameras. So we have all these other cars kind of in the background here. And we actually don't want to monitor those right now. For this use case specifically, we only want to look at cars in this drive-through line. So what we can do is kind of draw out an area saying, we only want to start tracking and detecting cars if they fall within this pixel range of our video feed. So that's a way that you can, make sure that you're actually getting the right insights that matter to you in your business, not just a bunch of noise around in the background of the video, and specifically in this use case. So once we have that area mapped out, we will then want to run our computer vision detection model, on that live video here. And in this case, we're doing object detection or instant segmentation. So you can actually see each car is basically being detected by the exact pixels that are defining that car. And then we're drawing a bounding box around it. So we know like where they are in the frame. And there's a bunch of stuff that you could do with that information. One thing that we're going to do is called object tracking. So we want to see when a car comes in, essentially sign a unique ID to it. And then as it moves from frame to frame in the video, we want to track the ID with that car, which can be a really hard problem depending on the angle of the video and how many objects there are. And we want to then calculate the dwell time. So we can say, well, we know, how many frames per second are coming in. We can now understand how long a car has been in the line for here. So once we have the model running in that specific area, what we want to really do now is tie that all together with our business data. And we've, now we can actually gain insights right away. So we have like a timestamp. We can see what time of day it is. We can calculate average wait time. We could even calculate, average wait time for different times of day. Here you can see that an abandonment happening in real time. It's, a car was in that area. We were tracking it. It's now leaving that detection zone. So we're like, all right, it's getting out of line here. We know it's an abandonment. And then we can calculate the total abandonments for the day or hours, whatever you want to track there, and then tie that back into, your business logic of like how much average revenue would that be from a car leaving. So we kind of went through all these steps of, collecting the data, labeling the data set, doing object segmentation with a machine learning model, object tracking only in a specific area, and then deploying it down to, in this case, this would be probably an edge device running with that camera. We can gain these insights. And then we often want to do something called continuous machine learning. So once we deploy that model, we often want to kind of keep collecting data on more cars and really monitor to make sure that the model's performing well over time. And if it's not, one way of fixing that is often, like I was saying, you keep collecting that data and then relabel it and retrain a model with that new data. So it's going to kind of make sure that, if a new car came in that wasn't maybe in the data set before, it'll have a higher confidence on detecting it.
So once we have this data collected and we have the ability to use it, it can be pushed into your kitchen display system or tied in with your POS system, or if you need, we can even create custom dashboards and so on. So it's really kind of depending on what you need and what you require for your particular use case.
Right, this could be something like live inside that the crew is seeing, or maybe it's an aggregate thing that you want to see at the end of the day, depending on your use case. So we're going to hop into another use case here and kind of break down how we might tackle curbside pickup.
Yeah, so I know some of you may or may not have drive-thrus at your restaurants. So we'll talk a little bit about curbside now. Curbside is on the rise too. I don't know about you, but when the pandemic was going on, I spent a lot of time going to pick up my food because there was no other options really. And the majority of restaurants actually, invested money in curbside during the pandemic, not just fast casual, but also fine dining. And we're actually seeing fine dining, increase and, making up a bigger portion of revenue in terms of the curbside usage. And QSR magazine actually said that curbside was the most popular option that people wanted. So whereas Drivethru has a wait time around 10 minutes, and on average, takeout, they're only going to wait like 4 minutes on average to get it right. So this is an important piece to watch out for. And of course, COVID-19, helped close that adoption gap because people are much more willing now to download an app. And so, Wendy's, Starbucks, Shake Shack, everybody's excited about the capabilities of Curbside and looking for ways to grow it and automate it. So I know Sage is going to walk you through sort of how that works, like we did for a Drivethru.
Yeah. Yeah, and I have also, like many people, been going to so many different curbside pickup solutions for different companies, and it's been fun seeing the adoption rate happen. All right, so this use case we're going to break down a little bit like we did for a Drivethru. You can see in this case it's kind of a little bit similar because we're tracking cars again, but there's a lot of differences happening here. So this again is kind of a camera up, already mounted. And instead of looking like it's a completely different angle, so we need to detect cars kind of more looking down. In this case, we're also detecting employees and customers. We can tell the difference between an employee and customer in this case because the employees are wearing specific uniforms, so they all have a reflective vest out in the parking lot, and the customers do not. And so we want to track cars just like we were before, but instead of being like one specific zone that we want to track them in, we want to see when they go into these parking spots. So each of these are a single specific zone. And once a car goes in there, we want to track how long has this customer been sitting there. So very similar to the Drivethru line, except for just kind of broken out into different segments here. So this is what the model looks like running. We're tracking a car, again, just like we were with the Drivethru. And then instead of making sure it's in a Drivethru line, essentially we start tracking it when it's sitting inside this parking space. And there's a lot of insights we can gather from this, right? Like we're tracking how long they've been in there. So how long are orders being taken to be fulfilled? Again, we have the timestamp, so you can get a lot of the data, like how many customers are coming and when is that, when are they coming? So you could increase staff at certain times. We get the average wait time. Here we're getting the number of cars currently waiting. So also like, oh, is there a lot of people out there? Maybe we need to divert some resources to fulfill these orders. We can also see how many of the spaces are taken. And it's actually kind of funny because it says, right, 7 out of 12 spaces are being used, even though 6 cars were there. And that's because this truck is kind of double parked, taking up 2 spaces. And we can track the amount of orders fulfilled. And then again, right, integrate that in with your business logic, however you need to be. So if you want to look at total revenue from curbside pickup or anything else you can think of that would work in this case. And how we did this was very similar to how we did the other use case, right? We did the data collection, we did the labeling, the data set, the object segmentation, the object tracking, again, specific areas, even though it's a little different, and then deployment. And then again, you'd want to have that kind of continuous ML piece to it, the integration, however you need it for your business. And then this just kind of highlights, right? Like we did all these things, but in a different area. And that just kind of goes to show how flexible all these solutions can be. And like I said, keep in mind, even though these use cases are both outside looking at cars, you can do things like this inside the restaurant or inside other different locations and look at things like people or different objects, right? It doesn't always have to be cars.
Yeah, I would point out here too that the camera placement is pretty important, and sometimes there's some experimentation that goes on to figure out where the right placement is for a particular restaurant, because they're all different layouts and things like that. So we'll help. Don't worry, we'll help you through that process and help you figure out where they should go to get the optimum field of view.
Yeah, that's a great point. All right, so we're going to jump in and kind of explore some other use cases happening in the industry.
Yeah, so we talked about Drivethru, we talked about Curbside. There's obviously many others. We'll just touch on a few here. Of course, informing from a service perspective, automating those detections and alerts related to the volumes and wait times, setting customer expectations based on the wait time. So imagine pushing this data into an app that allows somebody to look at the different stores and figure out which one to go to based on what wait times are happening at each store. Also, from a customer experience perspective, if you have a VIP or loyalty rewards program, we can really help personalize that experience even further. Not only informing the crew of VIP arrivals and so on, but also looking at ways to help understand and predict what type of food is going to be ordered more often based on who's actually coming through the curbside or Drivethru. And then, of course, in the kitchen, there's all kinds of use cases around sanitation and compliance and so on. And then tracking, workspaces and workers in the back. So those are a few in that perspective. Go on to the next slide, Sage. And we'll talk just a little bit about, sort of what the future holds. I don't know if this is true for any of you, but we're seeing a lot of companies that are starting to use ghost kitchens for surging demand and, delivery only kind of options. And, there's really, computer vision can help solve a lot of those challenges in terms of ensuring that the standards that you have in your own store are the same standards that's being applied to a ghost kitchen. In terms of speed, quality, and service, and so on. And then, I mentioned briefly about operational compliance, but that's really important in terms of, tracking and automating the processes of cleaning and freezer checks and verifications that the safety precautions are being taken and all that kind of thing. And one thing, we didn't talk about is security in general. Most of you probably have some sort of security capabilities on site already. In many cases, we can use those existing cameras and begin to monitor behavior and all kinds of things that would allow you to potentially eliminate your video recording and notify sort of in real time and on demand what's happening from a security perspective on site. And then we talked about staffing a little bit, not only in the in the technology industry, but restaurants are having a lot of challenges with hiring and maintaining staff. I think that's happening across every industry right now, but we can help to, keep management and the teams informed of what's happening there in terms of predictive analysis and giving crews the ability to act before, issues come up. So lots of cool stuff coming down the road.
Super exciting. So we're going to talk a little bit about how to get started. And this first slide just highlights. So a lot of times when you talk to someone about, these types of applications, people focus on the machine learning piece, building the model, sometimes the data annotation piece. These are also two very important things, like collecting the right data, training the model in the correct way. But I just want to highlight, there's a lot more that usually goes on when you're deploying a computer vision model out into the world. So you have things like device management. So you're managing either those edge computational devices and cameras, right? Like that's where the data is coming from. How do you run the model on those images and frames, or how do you collect data from those cameras? You have the data collection piece. So just like I was saying, usually you're streaming in video from somewhere and you want to manage those files and be able to segment them and create data sets. You have the data annotation piece we briefly talked about before. We have the machine learning piece where you need to select the right model and select the right parameters to make sure it's going to run accurately on your video streams. Then you have deployment. How do you manage that model, deploying to an edge device or the cloud? You can push it up once and leave it there, but typically, like you're saying, there's this continuous ML piece where you're always kind of retraining models and making it better over time. So you need to manage like which ones go, to your device and when, and ensure that it's running properly once you deploy it there. And then you often have a version control, right? So like if you do update your model and it starts performing worse, you would want to roll back and go to another model and kind of keep track of which ones are performing well on data. Same with the data sets. You want to version control your data sets as well. This is important across all industries, but it can be really important across even very specific industries like the medical field or something where you need a little bit more insurance and tracking of your data over time.
So every brand has their own unique use cases that are specific for them that will bring them, greater ROI than maybe another, for example. So a lot of times what we do in terms of a rollout, how you get started, is really a proof of value. So we'll sit down with you and we'll help you understand, what should be the success metrics around this particular use case. We'll put those together. We'll understand. We'll give you a quote on, how much it costs. Typically, a proof of value is like a flat fee kind of approach. And then once we've rolled that out and hit those success metrics, then we'll provide obviously a production timeline and rollout. And typically we're starting with 1 or 2 stores, and if we have success there, then we'll start to roll it out to more stores. And then over time, similar to how we would continually train the model. We're continually training the process. We're adding new use cases and just growing the computer vision capabilities across the board as we roll out. So that's kind of the approach that we take. And, like I said, every brand is different. We'll be happy to work with you and talk it through with you and give you some advice on the best ways to create success for both of us.
And that's kind of the end of our slides for this presentation. So really want to thank everyone for joining, and hopefully you found something of value out of this or saw some really, cool ideas maybe you haven't thought about before using computer vision. So we'll be hanging around and answering questions if you have any. But I think, Denny, you can stop the recording, and then I'll share all these links if you want to follow